This lesson is on multi-step equations. The first example that we're going to do is 5 equals 5m minus 23 plus 2m. Now, we know that what we need to do is combine like terms before we can solve. So I have 5m and 2m. So what I know that is, since they're both positive, it's going to be 7m. I'm going to bring down that minus 23 and the 5. Now I have a simple two-step equation. I'm going to add 23 to both sides. Okay, and so that gives me 28 equals 7m. And then I'm going to divide both sides by 7, so m equals 4. Okay, so that's the first one. Let's see if you can do this got it on your own. I'm going to leave it right up here. Let's try negative 2y plus 5 plus 5y equals 14. Pause the video and try that. Alright, so my like terms are negative 2y and 5. They're different signs to subtract. 5 take away 2 is 3y. Bring down my plus 5 and my equals 14. Now the next thing I need to do is take 5 away from both sides. So then 3y equals 14 minus 5, which is 9. And divide both sides by 3 to get y by itself. Y is 3. Okay. So then the next one that we're going to do is 5x plus 2 equals 2x plus 14. Now what I do is I always tell my students to VC, okay, that's VC, meaning variables on one side, typically on the left, and constants on the other side of the equation, and it goes something like this. Okay, so I'm going to draw a fence and put my V on top of the left and my C on top of the right. Now, all my variables have to go here. What variable is already here? I have 5x. And what variable is coming over is a positive 2x. If I'm changing the side of the fence, I have to change the sign. So positive 2x becomes negative 2x. And then all my variables are on the left side of the equation. Now my constants. What constant is already on this side of the fence? It's 14. And what constant has to move over is a positive 2. But if it changes the side, it changes the sign. So positive 2 becomes a negative 2. So then just combine like terms. 5x minus 2x is 3x. And 14 minus 2 is 12. And now I have a one-step problem. Divide both sides by 3. X is 4. All right, now let's see if you got it. Okay. We have 7k plus 2 equals 4k minus 10. Pause the video and try it now. And what we're going to see is that we're going to VC. Here's my fence. What variable's here? 7k. what variable is coming over. It's a positive 4k. Changing the side changes the sign to a negative 4k. What constant is here? It's a negative 10. And what constant is coming over? It's a positive 2, but it's changing the side, so it changes the sign. And now combine like terms. 7k minus 4k is 3k. And negative 10 minus 2 more, keep change. So I have negative 10 plus negative 2 is 12, and I know that it's going to be negative because both of my signs are negative. And I have a one-step equation. Divide both sides by 3, k equals negative 4. Don't forget the sign. This is a bad thing to a good person divided by that positive. Okay? So now what we're going to do is look at this this bottom part of the page. We'll end up folding it towards the bottom. But let's take a look here. Okay? Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. And Martha's niece wants 1 shirt and 4 bumper stickers. Her nephew wants 2 shirts and no bumper stickers. If her total is $67, what is the cost of one of the shirts? Well, let's see. We're going to first look at each of the parts of what's being given to us. So bumper stickers cost $1 each. Okay, her niece wants 1 shirt and 4 bumper stickers. Okay, so what the niece wants is 1 shirt and 4 stickers. The nephew wants 2 shirts. And then I also, here, let's circle our numbers so we keep it straight. 2 shirts. And her total is $67. So the total spent was $67. Okay? Now we're going to need to define a variable. The variable is always going to go back to your question. What does the question ask? 1 shirt. So probably what I would do is leave it as S for my shirt. So S is the cost of 1 shirt. Cost of 1 shirt. So now I need to write a little bit of an expression for each of these things here before I can form my equation. I have 1 shirt, okay, so that's going to be S. But her niece also got 4 stickers. The stickers cost $1 each. So how much did all the 4 stickers cost? $4. That's what the niece got. The nephew got 2 shirts. Well, if it's 2 shirts, I'm multiplying the cost of the shirt by the number that he got. That's 2S. And the total spent was $67. Now I have to look at the operations that are going in between them. So obviously that this total tells me here there's an equal sign for 67. And all of these words, and her nephew wants this, is going to represent an addition. And now I can solve. So combine like terms. I have S and 2S is 3S. Bring that across, plus 4 equals 67. Subtract 4, 3S equals 63, and divide by 3. Each shirt costs $21. Okay, perfect. Now let's move on. Try this one on your own. Noah and Kate. Pause the video and try it. Noah and Kate are shopping for a new guitar, strings, in a music store. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The cost of the book is $16. Total cost, $72. Excellent. We're going to do the same thing. You should have done the same thing as you did up here. What does Noah buy? What does Kate buy? And how much was spent? Okay. We also need to name our variable. Go to your question. 1 pack of strings. Okay. So strings is going to be our variable, the cost, I should say, of strings, the 1 pack. So Noah buys 2 packs of strings, so 2s. Kate buys 2 packs of strings, so 2s, and, meaning the plus word, a music book, but the music book cost $16, so I can just go ahead and put what Kate spent was also that $16, and the total cost was $72. And again, since I'm finding that total, I'm adding all of their costs together. There's the addition, and there's my equal sign, because that's how much they spent total. I'm going to combine my like terms. 2s and 2s is 4s. Bring down my plus 16 equals 72. Two-step equation. Subtract 16 from both sides. 4s equals 56. Divide both sides by 4. S equals 14. So each pack of strings cost $14. That is a lesson on multi-step equations.